Just imagine for a moment, stepping back from our planet. Not just looking down from a plane or even low orbit, but really stepping back. Looking at Earth from the moon. What kind of perspective does that give you? What might it reveal about our world? Maybe even about us? Today, we're doing a deep dive into exactly that, humanity's incredible journey of observing Earth from the moon. We'll look at the very first photos, their really profound impact, and even some pretty ambitious ideas for a permanent Earth observatory actually on the moon. Our mission here is to unpack the technical wizardry behind getting those views and also understand the unique insights they give us. We've gathered some fascinating stuff, historical NASA reports, articles on the environmental awakening these images spark, and academic papers on future lunar science. So let's kick things off right at the beginning. The very first time we managed to capture Earth from the moon. I'm guessing it wasn't an astronaut snapping a picture.
That's right. You might think Apollo, but no, the actual pioneer was robotic. It was Lunar Orbiter 1 back on August 23rd, 1966 that took that historic first photograph.
Lunar Orbiter 1, okay.
Yeah, and its main job wasn't even getting that Earth picture, really. It was part of a much bigger mission to map the lunar surface, basically scouting landing sites for the Apollo astronauts who would follow a few years later.
Right, 1966.
Yeah.
Well, it's pretty early in the space race. What was this probe capable of? I mean, the technology must have been pushed to its limits.
Oh, absolutely. It was an astonishing piece of engineering for its time. This probe didn't just take a quick look, it mapped a huge amount of the moon. We're talking over 262,000 square kilometers of the side we can see from Earth, plus another 3 million square kilometers of the far side.
Wow.
And the detail was incredible resolutions down to 8 meters on the near side, 30 meters on the far side. Think about that, seeing features that small from lunar orbit in 66.
It's genuinely hard to wrap your head around.
Yeah.
So how did they actually do it? How did a camera work out there, and how did they get the pictures back?
Well, it involved some really clever kind of Rube Goldberg-esque engineering. Lunar Orbiter 1 had this dual-lens camera system, a high-res 610mm lens and a medium-res 80mm one. They exposed actual film.
Film? In space?
Yep, actual film. And here's the amazing part. It developed the film on board the spacecraft.
No way.
Seriously. Like a tiny automated photo lab hurtling around the moon. Then, once developed, the film was scanned electronically line by line, and the signals were beamed back to Earth as radio waves. The whole system was tucked inside a pressurized, temperature-controlled canister.
A miniature darkroom in space.
Yeah.
That's incredible. Surely something that complex must have had some issues. Glitches.
Oh, definitely. Perfection wasn't quite achieved on the first try. The high-resolution camera's shutter, for example, turned out to be sensitive to radio interference from the spacecraft itself. Yeah, so that caused smearing on quite a few of the high-res images, unfortunately. But despite that, they still managed to get a good number of really clear, high-quality shots, especially early on and from higher altitudes. So, a huge success despite the hiccups.
Okay, so that was the very first picture, a robotic first. But there's another image, probably the most famous one that most people think of.
Yes. You must mean Earthrise. That one was taken by an astronaut. It was Bill Anders during the Apollo 8 mission on Christmas Eve, 1968. And that was a huge milestone, the first time humans had ever orbited the moon.
Apollo 8. Just imagine being there.
Anders was by one of the side windows as they came around from the moon's far side on their fourth orbit, and suddenly there it was, Earth rising over the lunar horizon.
What did he say? What was his reaction?
He described it really vividly. He called it this very delicate, colorful orb, which to me looked like a Christmas tree ornament coming up over this very stark, ugly lunar landscape. Apparently, he later said he wished he'd taken more photos.
I bet.
And Apollo 8, of course, was absolutely critical. It proved the systems worked, paved the way for Apollo 11 landing just, 7 months later in July 69. But that single Earthrise photo, its impact went way beyond space exploration.
Yeah, that image feels like it became something much bigger than just a photograph. It seemed to strike a chord culturally, maybe even environmentally.
Yeah.
What was the impact back here on Earth?
Oh, the impact was profound, huge. Many people credit Earthrise with really galvanizing the modern environmental movement. Remember, this was 1968, a time when environmental awareness was really starting to build globally.
Right.
The nature photographer Galen Ryle actually called it the most influential environmental photograph ever taken.
Wow. Most influential. That's a big claim.
It is, but you can see why. It wasn't just a pretty picture. It fundamentally shifted perspective for a lot of people. It created this powerful sense of Well, reverence, maybe, and
Yes.
responsibility for our planet.
It's a sense of shared home.
Exactly that. Astronauts who've seen it from space often talk about this kind of dual feeling.
Hmm.
On one hand, the Earth looks incredibly small, almost insignificant against the blackness of space. But at the same time, there's this overwhelming love and awe for its beauty, its uniqueness, the fact that it's our only home. Jim Lovell, also on Apollo 8, had that great quote about looking back and seeing the Earth's atmosphere appearing no thicker than the skin on an apple. Really drives home how fragile it all is.
It's fascinating, though, that contrast, because today you see these incredibly detailed, high-resolution images from space, maybe from the ISS or newer probes, and you often hear people say, that looks fake. It's all over social media comments. Why do these real images sometimes strike us as unreal?
Yeah, that's a really interesting point about perception. It boils down to a few things, mostly how our brain interprets visual cues based on our experience here on Earth.
Okay.
So first, the lack of atmosphere. Here, even on a clear day, distant things get hazy, softer. That haze gives us depth cues. In space, in a vacuum, everything is razor sharp no matter the distance. That can make things look weirdly close or sort of flat, almost pasted on.
Like there's no distance gradient.
Precisely. Then there's the lighting. Without an atmosphere scattering sunlight, you don't get soft, diffused light. You get incredibly harsh, direct sunlight and pitch-black shadows. Very high contrast.
Right, like old computer graphics sometimes.
Exactly. It can look artificial to eyes used to Earth's subtle lighting. And another big factor, especially on the moon, is the lack of familiar reference points. No trees, no buildings, no clouds of a familiar size. It makes judging scale really difficult. A mountain range in the distance might just look like a small row of hills.
That makes sense. Your brain doesn't have the usual cues to work with.
And one more thing, many of the most stunning space images you see today aren't single snapshots. They're often sophisticated composites stitched together from multiple photos, maybe even different types of sensor data. That process, while creating beautiful results, can sometimes add to that slightly unreal feeling for some people.
That's a really good point about composites. So going back to the emotional impact, we talked about Earthrise fostering awe and connection. But then you have other famous images like Carl Sagan's pale blue dot that one often evokes a sense of, well, smallness, insignificance.
Absolutely. And connecting this back, both reactions are completely valid, deeply human responses to seeing ourselves from the outside. Earthrise, viewed from relatively close by from the moon, really emphasizes Earth's vibrancy, its life, its isolation as a haven against that stark lunar backdrop. It pulls you in, fosters that sense of shared home. The pale blue dot, though, taken by Voyager 1 from way out past Neptune, about 6 billion kilometers away, that hits differently. It shrinks Earth to less than a pixel. That perspective can absolutely trigger feelings of cosmic insignificance. It kind of echoes what the philosopher Blaise Pascal wrote back in the 17th century, that feeling of terror, contemplating the eternal silence of these infinite spaces.
Wow, Pascal. So one shows connection, the other maybe isolation.
In a way, yes. Neither image tells the whole story, right? They just highlight different facets of our existence. Earthrise emphasizes our world. Pale blue dot emphasizes our place, or lack thereof, in the vast cosmos. Both profoundly shape our perspective.
Okay, so we've gone from the first grainy images to these iconic perspective-shifting photos. Let's pivot now and look forward. What about putting a permanent scientific eye on the moon, specifically to watch Earth? What could that actually achieve?
That's a really exciting prospect, the idea of a dedicated lunar Earth observatory. Scientists have been talking about this for a while. You picture a sophisticated telescope, maybe with instruments like diffraction gratings. Those are like super prisms for analyzing light-specialized cameras, radiometers, all set up on the lunar surface, constantly pointing back at Earth.
Like a permanent watchtower.
Exactly. NASA actually looked into concepts involving a manned lunar base with this kind of observatory back in the 2000s. Those specific plans didn't move forward then, but the core scientific idea is still very compelling.
So beyond just getting a cool view, what are the big scientific wins, especially for things like atmospheric science or climate change research?
The advantages are pretty significant. First, the view itself. From most places on the moon's near side, you can see the entire Earth disk all the time. As the moon orbits over about 28 days, you get to see both the sunlit side and the night side. And because Earth spins much faster,
Right, once every 24 hours.
you basically get a view of almost every single point on Earth's surface within one day. This allows for continuous monitoring of specific spots for hours, much longer than a satellite in low Earth orbit that zips over quickly. And you get fantastic, clear views of the poles, which are so critical for climate.
So it's about persistence of view, seeing changes over longer timescales without interruption. What specific things could we measure better?
Well, it would be a game changer for atmospheric composition. You could track gases like ozone, CO2, pollutants like SO2 and NO2, and aerosols with high precision over time. There's also a technique called stellar occultation. That's where you watch a star as it passes behind Earth's atmosphere from your viewpoint. The starlight gets filtered through the atmosphere, and by analyzing how the light changes, you get a profile of the gases present. From the moon, this process happens much more slowly, about 8 times slower than from low Earth orbit.
Ah, so you get much more data, more detail.
Exactly. Much more detailed studies become possible. You could track things like dust plumes coming off deserts, maybe understand their links to phenomena like hurricane formation over the Atlantic better. And crucially, a lunar observatory would be perfect for measuring Earth's overall energy budget, the balance between incoming solar radiation and outgoing heat. You could monitor this global energy balance constantly, track planetary brightness, understand the complex role of clouds, all under different lighting conditions throughout the lunar month.
And the moon itself offers advantages as a platform.
It does. It's incredibly stable. No atmospheric drag, no need for constant orbit corrections like satellites. It's seismically very quiet compared to Earth. The temperature swings are big from day to night, but they happen over a long, predictable monthly cycle, which is a different engineering challenge than the rapid heating and cooling satellites face in orbit.
Is it actually feasible, though, building and operating something like this on the moon?
Well, the challenges are obviously huge, the dust, radiation, temperature extremes. But missions like China's Change-3 lander, which operated a small ultraviolet telescope on the moon for quite some time, have shown that it is possible to do sophisticated astronomy from the lunar surface. The scientific payoff is potentially enormous. Finding the right spot, maybe a deep crater near the equator on the near side for some natural shielding would be key.
So we've really covered a lot of ground here, from those first kind of blurry robotic glimpses of Earth to the incredibly powerful Earthrise image that really changed how we saw ourselves, and now looking ahead to maybe having a permanent, dedicated scientific outpost on the moon watching over our planet. It's quite an evolution.
It really is. Our view of Earth from the moon has gone from being, a technical curiosity to a deep source of emotional connection, and now potentially a critical tool for understanding and protecting our climate. What this whole journey highlights, I think, is not just our technical cleverness, but this unique human ability to feel both profound awe and conduct rigorous analysis when we get that kind of grand perspective on our home.
It leaves you with a pretty big thought, doesn't it? Looking forward, if we do manage to set up this continuous objective watch from the moon, gathering all this unprecedented data on Earth's health, will that constant gaze finally push humanity together to really protect this delicate, colorful orb, as Anders called it? Or could the sheer scale of the problem, seen starkly against that vast, silent space, actually make us feel more powerless, echoing that old Pascalian dread of our own smallness? It's something to think about as we keep looking outwards and back at ourselves.